Hey guys, sorry I can't be with you today. Trying to take care of my boys and get healthy myself. So, apologize again for not being there, but family first. At any rate, we're going to move on to 3-2, which is solving inequalities using addition or subtraction. This is a lot like solving equations with addition or subtraction. So, the main point here is that you're going to want to use inverse operations. And just be careful that each of these, because it's going to have multiple solutions, because it is an inequality, you're going to make sure to graph the solutions, I believe. So for the most part, that is kind of the simplicity of the lesson. So let's go ahead and get to it. First, we'll start with our I can statements in our vocabulary. So we're going to be able to use addition or subtraction to solve inequalities. And we're also going to, oops, sorry about that. Why this isn't working, guys, sorry. Well, you get it, addition or subtraction. Vocabulary, we're talking about equivalent. Equivalent inequalities are inequalities that have the same solution. Let's see if that does the trick. Hey, look at that. So equivalent inequalities are inequalities that have the same solution. You're going to see a variety of those. The addition of property and subtraction property of inequality applies here. So you've seen the addition and subtraction properties of equality, which tells you that adding the same thing to both sides of the equation does not change the fact that they're equal. It will also not change the solution. Likewise, with inequalities, adding or subtracting the same value from both sides does not change the fact that they will have the same set of solutions. Also does not change the fact that the comparison symbols will be there and not change. For example, adding 3 to both sides, if I have 5 greater than 4 and I add 3 to both sides, 8 is still greater than 7, so it's not going to change anything. Likewise, subtracting, if I have 3 minus 1, 3 is greater than negative 4, and subtract 1 from both sides, 2 is still going to be greater than negative 5. That's the main idea behind the property of equality. If one side is equal, if one side is greater before adding or subtracting, it's still going to be greater afterwards. If it's less, it's still going to be less afterwards. Using the addition property. Okay. What are the solutions of this inequality, and graph the solutions? So very simply put, you're going to implement the same strategies as you did for solving equations. We're going to treat the comparison symbol like it is an equal sign. I'm going to go ahead and add 15 to both sides of this because I see subtraction, which means I'm going to do the opposite. Minus 15 plus 15 is going to cancel. We'll be left with x is greater than. Make sure you copy the sign down. Negative 12 plus 15 gives me positive 3. Alright, so be careful with the integer operations here. X is greater than 3, so what we saw yesterday is that we can graph this solution on number line, which is exactly what I'm going to do. Here's 0, 1, 2, 3. Go ahead and label 0, label 3. No equal bar underneath, which means it's going to be an open dot on 3. And greater than looks like greater than this way. So I'm going to shade this side of the number line. That means that everything bigger than 3 will make this true. 4, 5, 6, 7, 99, 1 million, you get the idea. Okay. So take a minute and try the next one. Pause the video now and work it out on your own, and then you can come back to the video when you're done to check it. So based on the fact that you have subtraction, I'm going to add 5 to both sides. It gets rid of it on the left. I'm left with n. The less than sign comes down. Negative 3 plus 5 is positive 2, so I get n is less than 2. I graph that on a number line. There's 0, there's 2. It's an open dot on 2, shaded left. Okay, if you don't have any issues with that, then we're moving on. If you do have an issue with that, go ahead and play it back, rewind, and see it again. Okay, so a couple of different things here. First, you're going to notice the equal bar. You're also going to notice that this first example is written backwards. So my personal recommendation, just based on the fact that you're going to have to graph this, would be to flip the whole thing around like you did yesterday. So I'm going to move the x minus 3 to the left-hand side. And notice which way the sign is facing. It is opening toward the 10, which means when I flip it around, I'm going to have the sign opening toward the 10. So now it becomes 10 is greater than or equal to x minus 3. X minus 3 is less than or equal to 10. Either way you look at it, 10 is the bigger value. Okay, so when you flip it around, be certain to flip the symbol as well, the comparison symbol. So from this point, I'm going to go ahead and add 3 to both sides because it is, again, subtraction, which means I need to do the inverse operation. You know what's going to happen here. That's going to go away. I'm going to have x is less than or equal to 13. Graph the solution. Okay. I'm going to put 0 down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Don't get lazy with that. Here's 13. Now, with the equal bar, this is going to be closed. And this sign is going this away. So I'm going to go ahead and shade toward the 0. Which means that 13 and everything less than 13 will be a solution. Check the solution. Okay, so anything on this line should make it true. Let's choose 0. 0 is less than 13, right? So that's a fact. 2 is less than 13, great. 13 is equal to 13, so technically that works also, right? You can do those checks mentally. Try the next one on your own, please. Solutions of m minus 11 greater than or equal to negative 2, and graph those solutions. Pause the video now, work it out on your own, and then resume the video when you're done. So what you see here is adding 11 to both sides will get rid of the 11 from the left. Negative 2 plus 11 is positive 9. Oh, excuse me. So what I have then is a solution m is greater than or equal to 9. So I'm going to plot my 0, I'm going to plot my 9. The equal bar underneath means that I have a closed dot, and this sign is pointing that direction, so I'm going to shade that direction. Okay. It does not ask me to check, so I'm not going to. If you have questions, go ahead and play that back, otherwise we're moving on. Now we're going to use subtraction property, which simply means we're going to subtract the same amount from both sides. You're getting the hang of this, hopefully, so far. It's really no different than solving equations, with the exception that you have a comparison symbol in the place of the equal sign, and you have to graph the solution on the number line. So subtracting 6 from both sides gives me negative 4 minus 6, which is negative 10. T is greater than negative 10. So on my number line, 0 is going to be on the other side now. 0 is going to be down here because I'm plotting negative 10, which is going to be way over here somewhere. I might consider avoiding all the hash marks and just going negative 5 and negative 10. Open dot on negative 10, and it's going that direction, which is this away. So I need to be shading in a positive direction. There's my solution. T is greater than negative 10. Graphed on the number line, open dot, going right. Your turn for the next one. Again, don't forget, I recommend flipping this around. So if you need to look back to the previous example to remind yourself how to do that, go ahead. Otherwise, try this one on your own. Pause the video and resume when you are done. Alright, this one got a little sloppy on me just because I'm trying to use the keypad mouse here. But you're going to flip the whole thing around, which don't forget to flip the sign. The opening is going toward the negative 1, so when I flip it around, the opening has to go toward the negative 1 as well. So I'm going to have y plus 12 is less than or equal to negative 1. Subtracting 12 from both sides gives me y is less than or equal to negative 13. And that is going to be a closed dot on negative 13. And going left, less is left, so going shaded to the left. If you have questions with that, go ahead and play it back. Otherwise, off we go again. Example 4, we're going to look at word problems. Okay. Whoops, that's way zoomed in. The hard drive on your computer has a capacity of 120 gigs. You have used 85. You want to save some home videos to your hard drive. What are the possible sizes of the home video collection you can save? Okay, so your total is 120 gigs, right? Capacity is the maximum. So it can be certainly less than 120 gigs, but it cannot be more. It could be exactly 120 gigs. So this is where we kind of need to think in terms of what that's going to look like. So I'm going to go ahead and write my symbol first before I do anything else, and have it be less than or equal to 120. Because again, the idea is that I can't have more than 120, but I can have exactly 120. I've already used 85. Okay, I've already used 85, which means whatever the situation is that I can save, I'm going to call it H for hard drive. Okay, I've got that situation plus the 85 gigs I've already used is going to give me the possible sizes of what I have left. So with this being said, I'm going to go ahead and subtract the 85 from both sides. Remember, I cannot exceed the 120. So subtracting 85 from both sides should give me 35. And less than or equal. So that means the possible sizes of home video collections would be 35 gigs or less. 35 GB or less. Can't exceed the 35. Okay. So I'm basically interpreting my solution here of H is less than or equal to 35 as 35 gigs or less. I can use exactly 35 or anything less than 35 for my home video collection. Okay. Hopefully that makes sense to you. Please pause the video, take a couple minutes to try the next example on your own, and then check back when you're done. So the key phrase here is at least 25 plants, which means I could sell exactly 25, and certainly I can sell more than 25. At least means 25 is the minimum, in other words. So it says club members sell 8 plants on Wednesday, that's represented by this amount. 9 plants on Thursday, that's represented by this amount. What are the possible numbers of plants a club can sell on Friday? So I'm using F to represent Friday. If I add those 3 days together, it can be at least, in other words, greater than or equal to 25. Okay, so I'm going to go ahead and combine my like terms. 8 plus 9 is 17, which I'm then going to subtract from both sides and get a solution of x is greater than or equal to 8, which means 8 is the minimum number of plants that I can sell. I can certainly sell more, but 8 is the minimum. So I'm going to represent that as, or analyze that as 8 or more plants. I could sell 8 or more. And that would meet their goal, obviously. Okay. Again, if you need to see that again or review anything, please feel free to rewind the video. Otherwise, you're going to have a few minutes to try some of these problems on your own. Let's see what we got here. Solve the inequality, graph the solutions. What are the solutions? Graph them. So basically 1, 2, and 3 are exactly the same, and number 4 is like that last word problem that we did. So take a couple of minutes to knock these out. When you're ready, please come back to the video. Obviously pause it now, work independently, and then when you're ready to review, unpause, take a look, see if you make sure, or I should say, make sure that you have everything situated before you move on to your independent work. Okay, so pause the video now and resume when you're ready to check. Alright, so we'll give you the first 3 first so you can check those, and then I'll take us another second and give you the last one. X is greater than or equal to positive 2, so 2 closed, shaded to the right. Number 2, flip the whole thing around and then subtract 2 from each side to get x is greater than or equal to 5. So closed dot on 5, shaded to the right. For number 3, add 4 to both sides, you get h is less than 8. open dot on positive 8 shaded to the left. So give me a second to do the last one. I'll be right back with you. I actually started doing this before I read the whole thing, so I had a completely different variable. At any rate, capacity of 275 means it cannot exceed 275. That's the maximum, so it can be less than or equal to 275. I don't know why it's in the order that it is, but the second part should actually be first. If U represents the amount of fuel used, and A represents available, then available plus used can be less than or equal to 275. The amount used is 135, so that gets subbed in for U. And then I'm going to subtract 135 from both sides to get A is less than or equal to 140, which means that you can use 140 gallons or less, or 140 gallons or less are available, I guess is what we should say. 140 gallons or less are available. Sorry for the crappy cursive, but that's the best I can do using the mouse pad. So hopefully that stuff makes sense to you. You are responsible for this right here, the homework, 174, 175, 13 to 43 all. Unfortunately, there are no IXL skills that go along with this, but if you do have extra time, you can work on any of the highlighted ones, knowing that today is the IXL poll. I'm probably going to get to that sometime this evening or afternoon, and that'll be a quiz grade for you in regular math. So, but obviously you have access to the algebra activities. Okay. I hope you all have a great day. You're probably going to get to this before lunch and then have independent time when you get back. Please use your time wisely. I don't want to hear about people being overly chatty or disrespectful or anything like that. So please do a good job. Have a great day. Hope to see you tomorrow.